This is the client, the proper command and control center of our project, and what ties together three separate devices into a network that is able to cooperate in order to complete the difficult tasks that we have demonstrated. This graphical user interface is written in Python using the PyQt framework and is able to handle up to 3 completely asynchronous client connections to Arduino devices, while also being able to send them commands, serve their responses, and exchange complex data types such as matrices and images over the network, all at the press of a couple of buttons. The prominent feature of this interface are the 3 login panes that we can see on the left side of the window. These panes are going to display all the logs that are sent by the devices and allow us to monitor them and see if everything is proceeding smoothly. On top of each of one, we have a drop-down menu that allows us to select which device we want to connect to, as well as a connect and disconnect button that allow us to toggle the connection to the device. On the right side of the interface, we have all the actions that we can take and the commands that we can send to the devices over the network. We have the sources sections. These sections allow us to select the source for each of the different data types that our network is able to request and send to devices. For example, we can select which device is responsible for image acquisition, so which device to send the command to in order to acquire an image. We can also select which device is supposed to perform the inference, so which device to ask for anomaly scores. And we can finally select which device to load or save weights. Here we can select where do we want the feature vectors to come from. And we have 2 options. We can select the feature vectors to come from the Arduino device. In that case, the device which is designated to the role of image embedder is going to acquire images through the onboard camera, embed them using our custom neural network, and then send the feature vector to another device which is responsible for doing the training. In the last section, the training and inference section, we have the concrete implementation of everything that we've talked about so far. We have the infer button and the threshold numerical input. The infer button requests an inference of whatever image is loaded inside this box. This image may have been loaded from disk or gotten through the Arduino itself. All in all, this client implements the interface to all the features that define our project and all the goals that we achieve through it, and ties together all the other subsystems that we've worked on into one functional, easy to use, and quite pretty package.